hopefully many week series of Fridays. Well, I'm sorry, I call it Fridays with Jim, but it's actually Mach 10. We promise to keep this to 10 minutes with respect for your time, as we know everybody, including myself, is webinared out at this point. The purpose of this drill is oftentimes we all run into questions when designing control systems, and it helps to be able to bounce ideas off of your peers. That is the purpose of this. We've asked Jim to present on some topics where we oftentimes feel ourselves questioning what's the right way to do this. I think that today's topic, complying with UL924, is a perfect kickoff, as it seems like every project we design, we say, do we want batteries and fixtures, generator, inverter, this, that, and the other thing, and then how do we make that integrate with controls? So, Jim, I'm going to go ahead and let you go with it. I should say that if you have questions, please just leave the questions in the chat, and we'll get to those afterwards. If you want to stick around and have a conversation, we'll be here as long as you want to be here. But if you feel like hopping off after 10 minutes, you're free to do that as well. So with that, take it away, Jim.
You're muted, Jim.
Hey, Jim, I don't know if you started talking or not, but you're muted.
Okay, there we go. Sorry about that. Wanted to make sure you guys could see the presentation. And so here we go. Today's topic is the UL924 devices that Drew introduced. And here we go. We have various approaches to meeting this code requirement. The most simplest is, of course, the battery, emergency battery in the fixture, if you don't have a generator on your project. And then a switch bypass device and Lutron's emergency lighting interface. And I will touch base on all of these in the coming slides. So let's start with the battery. Dimming and non-dim, of course, but the biggest thing that you have to remember is you need a constant hot from the emergency battery ahead of any wall control. So a switch, dimmer, aux sensor, even a relay in a lighting control panel. Need to get that constant hot ahead of that so that whenever that constant hot drops out, the emergency battery goes on to 100% to meet the code requirement. The next item is switch bypass devices, and two flavors of them. You have a non-dim and dim. So the non-dimming, you toggle switch with or without aux sensors, wall switch sensor, or even Lutron's Vive non-dim module. These can be used on the load side of those types of devices. This slide here illustrates, the normal power operation with power flowing through to both your normal and normal emergency lights. And then whenever the normal drops out, the emergency takes over and then brings your normal emergency lights on, regardless of the position of the switch. Dimming, basically the same thing, except wall box dimmer, wall switch sensor with dimming, or the Vive dimming pack. 0 to 10 volts, so you got the purple and gray wires going between the fixtures. And then again, when the normal drops out, the switch bypass locks in, takes the lights to 100%. And this slide illustrates the same thing as the non-dim, but with the purple and gray being locked out. The other option you have is whenever you have a digital system, which we'll call Cat5 with our scenario from HCS. Unlike some manufacturers, we have a dedicated UL924 emergency room controller. So basically, what happens is you feed it with normal emergency power, and the normal room controllers that are on the Cat5 network, when that normal power drops out, there's no signal on the Cat5, which it's the sense to the emergency room controller. And at that point, it kicks the lights on to 100% if they were being dimmed before. Let's move on to Lutron's emergency lighting interface. This device can be used across many Lutron lines, from Athena to Quantum, Graphic Eye, Energy Saver Node, and all the panel-based Lutron systems from GP to LCP. And basically what this device does, if you want to monitor all three phases or just a single phase, you can. And basically what happens is whenever it senses a loss of power to a phase, it sends a low voltage signal from this device to your dedicated emergency Lutron device panel, ESN, so forth, and puts that into emergency mode. And then that device goes to your predetermined emergency mode setting, typically 100%. And then we also have a wireless solution to be used with Vive. Basically, you have emergency 0 to 10 volt modules or non-dim modules that you can put into your application. It can be used with or without the Lutron hub, the Vive hub. Basically, if you have a hub and you lose power for 250 milliseconds, this emergency device, the relay closes, goes to full output. When the emergency is restored, it goes back to normal operation. But whenever it's an emergency operation, it will not accept a signal from an aux sensor, a wall control, daylight sensor. It stays in the emergency mode, regardless if it sees occupancy or someone touches a wall control. Now, if you have without a hub, again, 250 milliseconds, the relay closes, and it stays locked into the emergency position for 90 minutes. So it will not accept any anything from the aux sensor or wall controls or daylight sensors. It will stay in the emergency position for 90 minutes. When the normal is restored, it will go back to accepting sense and user control. And this diagram illustrates the normal flow coming through, and obviously with the emergency, with only the emergency fixture working. And then the dimming of the same application. We have a chart here that illustrates that the emergency control device that you would like to use, and then what systems you can use that on. So basically, emergency battery can be used across everything, switch bypass across everything. Of course, the room controller from HCS, the NX series, can only be used on NX. The Lutron, Lut ELI, Athena, QS, Quantum, any Lutron panel is included with that. And then, of course, the Vive wireless modules can only be used on Vive. Any questions?
I have a quick question.
Go for it.
So typically when we are doing large buildings, things like that, we always kind of opt for the emergency battery option within the fixture if it's available with that fixture. Where do you see that people don't use the battery option? Is it when they don't, is it when they don't have it available in the fixture and they don't want like emergency lighting, or what's the case where like you wouldn't just opt for battery in the fixture?
So if you have a generator on your job, a lot of times they do not put batteries into the fixtures because and they use the emergency source from the generator, just because it's another item that needs to be checked inside the fixture with the battery to be tested to make sure it is still working, things of that nature.
Okay, cool. Thank you.
Mm-hmm.
Any more questions out there?
And Jim, how does that work with inverter system?
Pretty much the same way. So if the inverter is not a UL920, doesn't have a UL924 listing to it, so that basically to do that you would have to have a output of the inverter room specific, and have the inverter, once it turns on, it turns those lights on just for that space. But the problem with that also, you should probably have a switch bypass device so that it does turn the lighting to 100%. Because if the inverter comes on, and the space is, say, dim to a daylight setting, it doesn't come on to 100%, so it doesn't really meet UL. Does that answer your question?
Yeah, I guess that does.
Any more questions? Jim, you did such a good job. No one has any questions. Okay. I believe you can find these. We are going to be posting the links to some of the products used and some of the slides we presented on the website, correct? At policelliwanza.com/mock-10. Can someone confirm that? Jim, Christina?
That's correct.
Perfect. In addition to that, if you have any further questions, you can reach out to any of the people that Jim had listed there or your OneSource salesperson, and we'd be happy to assist in any questions you may have. So with that, have a great Friday. Have a great weekend. We'll see you guys next week. All right. Bye, everyone.
Thank you.
Thank you.
Thanks, Jim.
Thank you.
Thank you.
Thank you.
See ya.